Okay, let's dive right into this explainer and find the back door into literally every data modeling and logical schema question, so you can start working smarter, not harder. Welcome, everyone. If you're turning in, you are likely staring down the barrel of the Cambridge Computer Science exams. Whether you're tackling foundational IGCSEs or the advanced 9618 papers, you've probably noticed something incredibly frustrating. You can memorize the entire textbook front to back, but when you actually sit down with a past paper, the marks just don't add up. Why is that? Well, because Cambridge isn't just testing your memory, they're testing your analytical architecture. Today, we're going to crack the marking rubric wide open. Imagine two students taking the exact same exam. First, we have Alex. Alex overloads answers with raw computer science facts, basically just dumping textbook definitions onto the page, but includes absolutely zero analysis. Then we have Sam. Sam rushes the paper, sweats through the time limit, and completely misses the specific command word requirements in the prompt. We are going to make sure you never, ever make their mistakes.
Now, what's really interesting about this quote is that it sets the ultimate challenge directly from the examiners themselves. The senior examiner for Cambridge explicitly noted that data modeling and logical schema are the great dividers of students. It's like the ultimate filter. A B-grade student can tell me that a primary key uniquely identifies a record. Okay, great. But an A-star student? They can explain exactly how a composite primary key resolves a tricky many-to-many relationship in a logical schema, creating a link table that strictly maintains referential integrity. Do you see the difference there? One is just a static fact. The other is a dynamic, applied system. The A-star student actually visualizes the data moving. Examiners are desperately looking for candidates who can demonstrate that higher-order thinking.
So, here is our masterclass roadmap to give you the inside scoop. 1. The A-star difference. 2. Core principles. 3. The standardized sequence. 4. Evaluating quality. And 5. Top examiner warnings.
Let's start with Section 1, the 8-star difference, where we look at superficial breadth versus conceptual mastery.
We constantly see students like our friends Alex and Sam who overload their answers with raw facts. But what the examiners actually require is logical, structured reasoning, and analytical depth. Let's say the prompt asks you to evaluate the use of third normal form in a hospital database. Sam completely ignores the word evaluate and just hastily defines the normal forms, minimal marks. Alex writes a massive essay on atomic values and dependencies, but completely forgets the hospital context. Again, massive points lost. To grab those marks, you have to decode the command words and use the PEL framework. That's point, evidence, explanation, link. Your point: third normal form prevents data anomalies in patient records. Your evidence: removing transitive dependencies means a doctor's phone number is only stored once. Your explanation: this prevents update anomalies that could lead to life-threatening miscommunication during an emergency. Your link: therefore, while third normal form requires complex query joins, it is absolutely essential for a hospital database. Now that is analytical depth.
So, the absolutely crucial point here is mastering the method mark strategy. Multi-step calculations and complex modeling scenarios are exactly where unprepared students bleed points. When you normalize a conceptual schema, the examiner is essentially watching your brain work. If you jump straight from a messy flat file right to third normal form tables and you make one tiny error, boom, you lose everything. But if you explicitly draw out the tables in first normal form, identify the repeating groups, consciously move to second normal form by removing partial dependencies, and then finally create your third normal form tables, the examiner awards method marks for your logical steps. You literally have to prove how you got to the answer.
Before we continue, subscribe to our YouTube channel Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along to Section 2, Core Theoretical Principles. Let's see how the theoretical architecture builds your mark potential.
In data modeling, you simply cannot build a functional database without fundamentally understanding entities, attributes, and relationships. Examiners look for knowledge, sure, but then they immediately pivot to application. To achieve top marks, you must integrate these 3 core principles and apply your conceptual understanding to completely unfamiliar contexts. First up, precise definitions. A candidate key isn't just a key, no. It's a superkey with no repeated attributes from which the primary key is chosen. Second, causal relationships. If you change a one-to-many relationship to a many-to-many, what's the actual effect? Well, you must create an intermediary junction table to resolve it. Finally, cross-topic connections. This is a big one. If you discuss data schemas, connect it to data security. Logical schemas allow for different user views, which protects sensitive data, tying perfectly into your security modules. Examiners love that.
All right, Section 3, the standardized sequence.
This procedural framework is your blueprint for systematic processing.
This brilliantly illustrates the standardized sequence you must use to clearly show you're working and secure those vital method marks. Let's do a quick mental challenge to automate your sequence. Imagine the exam hands you a flat file of an airline booking system. Step 1. Identify key elements. Scan the text and highlight your entities. We have passenger, flight, booking. Step 2. Apply principles. You know a booking links a passenger and a flight, making it a junction table. Step 3. Execute analysis. Mentally or on scratch paper, draw the entity relationship diagram with the crow's feet pointing directly toward the booking table. Step 4. Verify results. Ask yourself, can one passenger have many bookings? Yes. Step 5. Present format. Write out your logical schema clearly, remembering to underline those primary keys. This exact sequence is what pushes your mark potential straight to 100%.
When applying algorithmic thinking, this specific decomposition sequence ensures efficient implementation and guarantees you hit all your assessment objectives. And guess what? It applies perfectly to schema design too. Data structure selection is exactly what you do when you are deciding data types in your data dictionary. Think about it. If an attribute is a phone number, you select a string, not an integer. Why? Because you need to store that leading 0. That right there is algorithmic thinking applied directly to data modeling. It shows the examiner you are looking 3 steps ahead to when this database actually gets implemented in SQL.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @actheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @actheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's jump into Section 4, Evaluating Algorithm Quality. Welcome to the workshop. We are going to test how well you can evaluate an algorithm's quality under time pressure. If you scan a complex data source, you need to extract specific metrics to compare approaches and justify your recommendations. Let's do Challenge 1, the data scan. Imagine a complex data table on your exam paper. You shouldn't be reading every single cell. Instead, you scan for repeating groups to instantly extract the core trend, like realizing the table isn't in third normal form. Now, Challenge 2, find the flaw. Someone suggests indexing every single field in a database to improve search speed. What is the flaw there? Well, while indexes definitely improve read speed, they negatively impact write speed and drastically increase space complexity. Every single new record forces updates to dozens of indexes, completely tanking performance. Extracting those metrics to justify your answers proves your higher-order problem-solving skills.
This Deconstruct Solve Evaluate workflow is your absolute go-to speedwriting template for evaluating alternatives. For Challenge 3, speedwriting, imagine you have to evaluate 2 schema designs. First, identify given information. Say schema A has some redundancy, but schema B is fully normalized. Second, break it into logical steps based on context. If the prompt tells you it is a read-heavy historical archival database, schema A might actually be better for performance since you don't have to join as many tables. Solve systematically, check the reasonableness of your claim, and make a highly justified recommendation. That is how you dominate evaluation questions.
For our final segment, Section 5, we are revealing the top 3 high-stakes warnings straight from the principal examiner reports.
Can you spot the flaw in your own practice answers? Make sure you never make these 3 mistakes. Number 1, confusing cause and effect. Students constantly draw relationship lines backward in their ERDs. Remember, a customer has many orders, not the other way around. Number 2, forgetting boundary conditions and edge cases. When you are defining data dictionaries, you have to establish validation rules. If you have an age field, what is the logical upper and lower boundary? You can't just leave it open. Number 3, answers lacking specific context. If the exam question is about a veterinary clinic, and you write a generic paragraph about users and items instead of vets and pets, you are throwing away easy marks. Always adopt the vocabulary of the specific scenario.
This right here is a massive red flag directly from the examiners. You must explicitly define your technical terms first before writing your extended explanation. If you're going to use a heavy term like referential integrity, start your sentence by stating that it ensures a foreign key value must match an existing primary key value. Don't just throw buzzwords onto the page hoping they stick. Prove to the examiner that you know exactly what the tools in your toolkit actually do. All right, this cheat sheet recaps the entire answering system we've talked about today. Decode your context, apply the sequence, and evaluate the quality to hit that 100% mark potential. It boils down to 3 rules. Rule 1, command word decoding.
If the prompt says state, give a straightforward fact. If it says explain, you better give the how and the why. Rule 2, PL framework application for all extended answers. Rule 3, the time management matrix. Allocate your time strictly based on the marks available. Please, do not spend 10 minutes writing a novel for a 2-mark definition question.
Students who implement these exact strategies consistently see an average improvement of 2 grade boundaries. But, and this is a big but, only if they practice consistently. You need to take this theoretical blueprint and apply it to actual past papers under timed conditions. You have to train your brain to see the underlying matrix of the exam so you instantly recognize when they are trying to trick you with the deceptive many-to-many relationship hidden in the prompt text.
Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here. Keep practicing those method marks, and I will see you in the next explainer.